Let's take a look at fitting these twin turbine electric fan shroud to the Nissan Frontier D22 Radiator. We are now going to continue this series by updating this dual electric fan shroud to a more professional and appropriate fan shroud. So we can see that there's evidence of this fan has been in operation for some time, approximately 300 to 400 miles, and the most difficult part in fitting this fan and radiator into the engine compartment is where the steering box is located. This here will have to be cut out so the fan and the radiator unit can be fit as one piece together. When we take a close look, you can see the steering box was actually riding up on this plastic, and this will generate vibration from the steering box or from the fan, and this will most likely be felt on the steering wheel. Also, since this fan is oversized in width and undersized in height, we're going to use a different fan shroud and blade for the same radiator. So we're basically going to disregard this fan shroud, which we had to relocate the posts. You can see we had to cut them out of here and place them into this location. Up here we had to do the same thing, just had to move it over a little. In the video description you're going to see the modification for this fan to make it fit to this radiator. So by now you will already know that this electric fan does not come or is made equipped for this radiator. Since this radiator is for a clutch fan, we are now adapting a electric fan to this radiator for more efficient cooling, quicker warm up, a little increase in horsepower and fuel consumption. So let's take a look at what this fan looks like. So here I'm going to place a new factory OEM, and you can see where the mount in position was relocated so the fan could be fit to the radiator. When we take a look at this side here, you can see this is our new location. This is where we had to relocate from. Now we want to do the same thing that we have done to this fan shroud to a newer fan, a more updated fan, a more efficient fan, and that will be something like this. So when we look at the blades, we can see the blades is already, this is basically a turbine blade. It's able to flow more air, and this fan shroud is a much direct fit for this radiator. So what I want to do here is I just want to take a good look at the new fan. So you can see this is a heat shield protector, but this is plastic, and the fan motor has holes in them for ventilation and air circulation. Flip this over. We take a look at this one here. You can see the difference. This has 4 blades. This have more blades. We can also notice these little metal for balancing the blade assembly when it's in rotation. There's another one. So that's the email you will need to contact me if you want this fan for your Nissan Frontier, Navara, Pathfinder, D22, R50 or R51. Another part is this fan blade will most likely strike that side right here where we place this cardboard, because the duct tape does not hold to the plastic. Since it's such an old duct tape, it's been sitting on the shelf for a long time. So this is all the reason why we're getting rid of this unit, because when this fan blade is to strike that cardboard, it's going to damage the motor, could damage the fan. With the old electric fan removed, we can now take a look at the fitting of the new dual turbine electric fan. So I'm going to pick this up, just to show you a direct fit. So this is perfectly fit on the side here, on the bottom, all along. On this side here, perfectly fitted on the top, and we can see this support will not need relocating. Only this one and these two. When we take a look at the old fan, we can see we had the cut here, so the assembly will fit where the power steering is located. On this one, we will not need to do that because this fan sits closer to the radiator core, allowing its blade to rotate freely. At this point, with the bonding agent, harden and fix the two pieces together. To ensure that these two pieces stay together, you may want to use some nuts and bolts like this with a washer, passing it through the fixture and bolting it from the other side. So this will require approximately 2 bolts for all the pieces that we have relocated for holding the fan shroud to the radiator. Here you will notice small pieces of duct tape was placed to cover any opening to promote airflow. You can also contact us at this email for any assistance with your electric fan installation. Placing these masking tape where the adhesive is being placed is essential for holding it fixed to the pieces for more rigidity. So that masking tape is going to be highly required in the corners for holding the bonding agent to the pieces where it's required. So what we have done here is petitioning the windows for the fan, since we have a left and a right. We do not want the fan to mix the air from the windows. So this petition will seat itself, all of this, against the radiator heat exchanger core. This will also restrict air from seeping by and the corners of the fan shroud, limiting the cooling efficiency of the fan against the radiator heater core. So now we're going to place this fan onto the heater core and seal the sides against the radiator, while these petitions will seal against the radiator core, allowing maximum airflow through the radiator heater core and the fan. Okay, so we have already established a petition on the inside. Now this will enclose the complete fan against the radiator. When we take a look in there, you can see that white. That's basically a petition between the two fan windows, allowing the fan to work independently. Let's take a look at this side. So one thing you need to know is both of these fans must operate together at the same time for maximum cooling efficiency. If one of the fans is to be used, we have to make sure we have that petition in the middle so it does not circulate the air from this opening to this opening, thereby restricting the airflow or avoiding airflow through the radiator fin. With both fans operating is the best way for cooling the radiator, like I've mentioned. So if we didn't have that petition between these two fans, operating one of the fans will become inefficient. But since we have placed that petition in the middle, this fan could cool this section of the radiator, while this section will remain at a higher temperature, offering a benefit to some sort. But the goal here is to operate both fans at the same time, even though it has the petition in the middle. So when we take a look at this bottom here, you see how we have that opening? Well, that will normally draw the air through that opening. So by placing that duct tape petition all along these edges on the top, will prevent that airflow from passing through the side of the fan shroud. Instead, we want it through the radiator fan core. By now you would figure that this fan shroud is much closer to the radiator heat exchange core. It's approximately 6 to 7 millimeter in distance when compared to this fan attached to the radiator. We had approximately 1 inch clearance between the side and the radiator. Once the bonding agent has been dry, it'll be the best time to spray paint that adhesive for sealing it from the weather and temperature. Okay, now it's time for us to install that radiator with the fan. You could also install the radiator first and then install the fan. It doesn't matter because we do not have any more clearance issue with that power steering box. As you can see, Steve is setting up this nicely into the radiator frame support. That's it. It's fitted into position. You can see the radiator is able to move back and forth at the top, letting us know the power steering box is not bracing the fan like it did with the other one. We can now place the top support for the radiator, install the hose, finish the connection, and take this vehicle for a test drive. Here you can see the problem with the steering box and the fan shroud has been solved by replacing the fan shroud with a new one that does not need any modification for fitting against the steering box, while the radiator fan unit is perfectly seated against the radiator support frame. With the coolant overflow reservoir in its factory location, this radiator fan unit is a perfect fit for the Nissan D22 Frontier. Here is the left side radiator to body clearance, which remained the same as factory. So is the right side and the coolant overflow reservoir, which is most important for the radiator. Another point to consider is this air conditioned condenser. The fin must remain clean and unrestricted so air can flow through. This gap between the condenser and the radiator on both the left and the right side must be enclosed so the air from the fan will be able to pull air through the condenser and the radiator in one flow. With the radiator fan wire circuit for automatic control, let's now enclose the engine compartment to monitor its temperature. Before the vehicle can be taken for a test drive, a start procedure must confirm that the engine does not overheat and the electronic engine coolant fan operate according to its preset value. With the engine cold started, we will monitor its length of duration time for it to reach its maximum preset operation temperature. The modification of lowering the engine temperature by changing its Fahrenheit degree may be done to vehicle operating in tropical or desert climate weather, and not to vehicle operated in cold weather conditions, will render performance of the passenger compartment climate control. Lowering engine temperature is to preserve coolant hose and gasket joint. A high temperature engine will exert high pressure, leading to possible overheating. Let's take a look at the scan tool for more accurate data information pertaining to the modification that was done of lowering the temperature and installing the electric fan. Here we can see code 328, which is a knock sensor related code and is a fault existing inside of the distributor. The information from here on is important to understand to gain maximum engine performance in relation to reduce emission deposits. Understanding the engine cooling system in relation to fuel and spark timing versus emission gas is one of the best ways for maintaining optimum long-term engine durability within preset engine operation temperature. By comparing the duration time between the electric fan and the clutch fan endured to reach maximum preset operation temperature is one of the goals in this live data acquisition. The electric fan radiator engine will reach its preset maximum operation temperature much quicker than the engine with a clutch fan, since the clutch fan will remain in rotation all of the engine operation time. This constant rotation of the clutch fan will most likely maintain a minimum airflow cooling rate to increase engine warm-up time to reach maximum preset temperature value, while consuming more fuel than the electric fan engine. The electric fan will remain non-functional till the engine reaches its maximum preset operation temperature for quicker warm-up time when compared to running clutch fan and reduce fuel consumption. To define the topic is to express upon the term known as open loop mode and closed loop mode. The engine runs the strongest when it is not fully warmed up, while it is in open loop mode. The goal of the open loop mode is to bring the engine to operation temperature with a pre-programmed ECU fuel timing calculation for closed loop mode function to maintain a 14.7 to 1 air-fuel ratio. Now the engine will operate in open loop mode since the thermostat and the coolant fan value has been lowered to approximately 170-180 degrees Fahrenheit maximum operation temperature. It will consume more fuel in cold weather climate condition and also when compared to closed loop mode in cold weather climate condition, but not likely in tropical desert climate environment. The engine may reach temperature above 200 degrees Fahrenheit to enter closed loop mode. Open loop mode may cause a rich running condition in both hot and cold climate weather, which can be monitored by the scan tool, short-term fuel trim, and the oxygen sensor live data. In some cases, the ECU will correct excessive fueling consumption based on engine temperature value. If the ECU fails to correct the overfueling to attain a 14.7 to 1 air-fuel ratio value or 0 short-term fuel trim, the technician can advance the distributor ignition spark timing with a timing light or advance the ECU timing table perimeter to increase the cylinder combustion gas burn rate to eliminate any harmful emission or excess fuel consumption, which can produce more power energy. Now that the engine maximum operation temperature has been lowered, to remain in open loop mode, the ECU will now reduce its operation cycle of recirculating exhaust gas into the engine combustion chamber for coolant purposes. The internal of the engine crankcase is less capable of carbon sludge buildup since a large amount of its deposit is from Egr valve function. The Egr valve helps eliminate carbon monoxide gas, which is created at high combustion temperature in wide open throttle or closed loop mode, relying on the oxygen sensor data. With the engine temperature lowered to a more safe operating temperature, the only deposit gas most likely to be fuel in the emission. A rich condition present in the emission gas can be eliminated by advancing the ignition spark timing distributor not to produce knock, ping, or detonation to the cylinders. Any detonation or fault leading to DTC code 0328 or DTC code 0327 will place the ECU into default mode, rejecting any manual adjustment or data calculation value for ignition, advance, degree, timing, and resort to default mode to protect the engine from damages. Engine temperature is critical to fuel consumption, oil stabilization, and wear and tear of the engine internal parts and related factors. Since the vehicle is operating in tropical weather condition, no changes to the distributor timing was made since the ECU value for short-term fuel trim remained the same. The distributor timing can be adjusted to control emission levels. If the short-term fuel trim show evidence of overfueling, a plus percentage is evidence of overfueling rich condition. A negative percentage is evidence of insufficient fuel lean condition. Short-term fuel trim can only be confirmed when vehicle is driving at wide open throttle or engine at idle with foot on the brake, apply press, gear in position, drive. The best reading for short-term fuel trim is 0% or negative 0% within a 10% range since the engine is over 100,000 miles. Now that the temperature is lowered, the short-term fuel trim will have a tendency to change like we see here because it's in the negative zone. But this is good because this is telling us it's taking away fuel for maintaining that same idle as when it had the clutch fan. Now if we should go wide open throttle on this engine, we will have an extra 3 to 4% of fuel at wide open throttle. This means the injectors will have room and the duty cycle of the injector will not be consumed up since the short-term fuel trim is not sitting in a positive percentage. You always want the short-term fuel trim 0 or below 0 in the negative zone. Now we're going to take a test drive. During the driving course, we want to make sure that the engine can maintain its temperature of approximately 170-180 degrees Fahrenheit. This we will know that the fan is cycling on and off, and due to driving the vehicle, the radiator is maintaining cold air. So here we can see the gauge is just below its median temperature for coolant, and that is what we want to see before we could make our test drive. We do not want a overheating condition. With the engine coolant temperature stabilized at idle and the radiator coolant fan automatically wired into the ignition, with the switch off, we will turn that switch on again and listen for the coolant fan. With the coolant fan on, this is an indication that the system is automatic, and we will now continue with a test drive. Now we're going to take a wide open throttle test drive. So we want to monitor the engine temperature, and as you can see, the fuel tank was filled above its halfway mark to increase the load of the vehicle during the course of accelerating at wide open throttle up the hill we are heading to currently. So what we want to look at is, we can see that check engine light just turned on since we have been driving for approximately 25 miles. Every time the check engine light is reset, it will reappear at approximately 25 to 35 miles of driving. This is a symptom of a misleading DTC code. What's happening here is that we're getting a code 328 as discussed before, but this code 328 is not a physical code, which means it's not happening in the engine. The engine is not detecting any knock or detonation. This code is caused because the distributor ignition module is malfunctioning, referencing its information from the crankshaft position sensor and the camshaft position sensor with the ECU. So we're going to disregard this check engine light and reset the ECU when the vehicle is ready for a wide open throttle test up that hill that will be best for load testing. So right now, when we take a look at the scan tool, we have arranged a different assortment of data information for acquisition. Before the engine temperature was lowered 2 years ago, DTC code 328 existed then and now, which is a malfunction in the computer system and not the engine. This is the roadway hill we are approaching for wide open throttle acceleration. We are going to flip from the top to the bottom of the screen, and you can see the engine coolant temperature sensor, short-term fuel trim, ignition timing. These are the three things we want to look at for this wide open throttle test. Okay, now we're at the bottom of the screen. We want to watch the ignition timing, TPS, and load. You can see on the open code, it's approximately 0.7 volt. TPS is at 88%, and the ignition timing is approximately 21 degrees. The CPU temperature is 180 degrees Fahrenheit. This is under extreme condition, climbing up that hill. We're going to try another test at a different hill. What we want to look at is the oxygen sensor voltage and the ignition timing. We already have confirmed that the engine is maintaining its preset maximum temperature regardless of driving conditions. So here is our ignition timing. Below that is the intake air temperature sensor. This is the ECT temperature sensor at the top. Now we're chain 17 degrees timing, wide open throttle. TPS, and O2 sensor voltage. Okay, now we're at wide open throttle. Sensor is at 740. The ignition timing is holding at 21 degrees. This is optimal. This is factory setting. This is what we want to maintain with the engine cooling temperature of approximately 177 degrees Fahrenheit. So this is the second hill, and the scan tool data, which is for monitoring purposes only. We're not changing any parameters inside the ECU or recalibrating anything. We're simply monitoring these sensors, and based on calculation, we can make adjustment in the ECU for producing more energy, horsepower. We first have to analyze these information before we could make those changes. That will consist of reflashing the ECU, closed loop and open loop mode by enriching or leaning out the fuel mixture, advancing the timing. So here again we have the TPS and the O2 sensor mode rising. The maximum on the O2 is a 680, 640 at 81% throttle. 640 is approximately 700 degrees Fahrenheit exhaust temperature. Once the vehicle is placed on a dyno with a tailpipe emission inspection, then optimum horsepower based on emission can attain. For now, we're just monitoring the factory OEM system for standard operation. Since we have lowered coolant temperature sensor or engine coolant temperature to tropical and desert climate condition. So what we have witnessed here is the maximum temperature the system will attain is approximately 182 degrees Fahrenheit, and it will mediate or operate stop and go condition at around 177 degrees. This temperature will fluctuate 5 to 10 degrees based on climate temperature condition. In a hotter climate, temperature may rise more to the 180 degrees. In a lower climate, temperature may settle at 170 to 177 degrees. So this have complete our test drive diagnostic test with the ECU reset. So this has bring us to the end, and we can see everything is up to standard according to the factory programming. Even though we have lowered the temperature, this have complete the modification of the electric fan, deleting the clutch fan from the engine. Thank you for watching this video. Comment if you would like. You can always subscribe. And again, thanks for your support. See you again with another video. 180 degrees Fahrenheit, the hose will develop no pressure. So is the radiator when open. It is never a good practice to open a hot radiator or exposing cooling system.